one is BPT, second is A.B.T, third is ITPL. Okay, what do you know BPT? Basic proportionality theorem. A.B.T means angle bisector theorem, and the third one is ITPL. It means intersection of three parallel lines. With this, we have to study converse of BPT and converse of A.B.T. Converse of basic proportionality theorem and converse of angle bisector theorem. Now let's start. The first one is BPT. See this triangle? In triangle ABC, segment DE is parallel to segment BC. If any segment is parallel in a triangle, then remember that we have to use basic proportionality theorem. It says that this line divides the two segments into two equal ratios. AD upon DB equals to AE upon EC. It means you have to remember one point. If a line is parallel in a triangle, then that line divides the other two segments into two equal ratio. This is called a basic proportionality theorem. Second part. This is triangle PQR. In the PQR, QS is an angle bisector. If in a triangle, angle bisector is there, then you have to use angle bisector theorem. What it says? It says that QP upon QR equals to PS upon SR. It means if any ray, any segment divide the angle, bisect the angle, it divides its segments into equal ratio. There is a simple trick to remember. Where is the angle bisector? At the point Q. So from put your finger on Q, then we can start QP upon QR. You have to start it from P point, PS upon SR. This is called angle bisector theorem. The third part is ITPL. It is very simple to remember. If three lines are parallel, here line AB is parallel to line PQ is parallel to line DC. Then we can say that AP upon PD, this ratio is equal to BQ upon QC. In all three theorems, you will find that the ratio is equal. The first one is BPT. You have to remember three tricks. If a line is parallel in a triangle, then always use BPT. Second, if angle bisector is there in a triangle, then use A.B.T. If three lines are parallel, then you have to use intersection of three parallel lines. Then what is converse of BPT? It says that if the segments are in proportion, then lines are parallel. Remember the point. BPT comes if the lines are parallel. And converse of BPT says that if the segments are in ratio, then lines are parallel. Same thing in angle bisector theorem. If the segments are in proportion, then that segment is angle bisector. So now let's start the sums, then we can solve one by one. We are going to see the first sum which is related to basic proportionality theorem. See in this triangle, this is a triangle ABC. In the triangle ABC, DE is parallel. Segment DE is parallel to segment BC, and the given thing AD is given 8, BD is given 6, and EC is given 12, and you have to find out AE. I know the trick. The line is parallel, therefore I am going to use basic proportionality theorem, that is called as BPT. So first you have to write it. In triangle ABC, segment DE is parallel to segment BC because it is given. Therefore, by BPT, you can write the shortcut BPT. Therefore, from vertex you have to start it. AD upon DB equals to AE upon EC. Now substitute the value. AD's value is 8, BD's value is 6, AE's value you have to find out it, and EC's value is given 12. Now what to do? Cross multiplication. AE into 6, then 8 into 12. You have to find out the values of AE. Therefore 6 goes on that side. You will get it AE equals to 8 into 12 divided by 6. 6 1 the 6, 6 2 the 12. So answer is AE equals to 16 units. This is your answer. So always remember this. If the line is parallel in a triangle, then you have to use BPT. Now we are going to see the second sum which is related to the angle bisector. Now see this triangle. This is triangle PQR. This is the line which is angle bisector here. PR is given 15, then PS, QR is given 20, RS is given 12. You have to find out SQ. So I know the point that PS is angle bisector. Therefore I am going to use angle bisector theorem. So what you have to write it? In triangle PQR, segment PS is an angle bisector of angle RPQ. Give the reason. This is given. Therefore, by angle bisector theorem. Don't write the shortcuts A.B.T. You have to write it angle bisector theorem. You have to start it from point P. Why? Because there is an angle bisector. So PR upon PQ. PR upon PQ equals to RS upon SQ. Now substitute the value. PR's value is given 15, PQ is given 20, RS is given 12, and SQ you have to find out it. Now cross multiplication. 15 into SQ equals to 12 into 20. Now 15 goes on that side. So SQ will get it 12 multiplied by 20 divided by 15. So 5 3s are 15, 5 4s are 20, 3 1s are 3 4s are. So SQ will get it 4 into 4, so 16 unit. This is your answer. This is sum which is related to angle bisector theorem. Now the third theorem is ITPL. This is very simple, because if the three lines are parallel, then we can use ITPL, means intersection of three parallel lines. Here AB is parallel to PQ, is parallel to DC. This is given 15, this is given 12, and this is given 14. And you have to find out BQ. So first you have to write it. Segment AB is parallel to segment PQ is parallel to segment DC. Therefore, by intersection of three parallel lines, I have written the shortcut here, but don't write the shortcut in exam. So what you have to write it? It says that it comes from upper to the lower. AP upon PD. From that side, BQ upon QC. AP value is given 15. PD is given 12. BQ you have to find out it, and QC is given 14. Now, what you have to do? Cross multiplication. BQ into 12 equal to 15 into 14. Now, I want to find out the value of BQ. So, 12 goes on that side. BQ equals to 15 multiplied by 14 divide by 12. So 3 4s are 3, 5s are 2, 4s are 2, 7s are. So your answer is 35 upon 2. 7 5s are 35 upon 2. So therefore you will get it 2 1s are 2, 2 7s are 14 and 2 5s are 10. So your answer is 17.5 unit. These are the three sums which are related: basic proportionality theorem, angle bisector theorem, and intersection of three parallel lines. Now we are going to see how to solve the sums which are related to the converse of BPT and converse of angle bisector theorem. Now observe this figure. This is P, this is Q, this is R, and there is a one line which is PS. Its value is given 3.5, its value is given 1.5, and its value is 7, and its value is 3. Now they will ask you the question whether PS is an angle bisector. Then how can we prove this one? It's very simple. If the ratio is same, then it will be angle bisector. Then which is the vertex? P. So from P you have to start it. First find out the ratio PQ upon PR. So PQ is given 7, PR is given 3. Therefore its ratio is 7 upon 3. Now we have to find out the another ratio. You have to start it from PQ, then you have to start it from Q. So QS upon SR equals to 3.5 divided by 1.5. If you cancel these digits, then it will get 35 upon 15. So we will get 5 3s are 15, 5 7s are 35. So here the ratio is 7 upon 3. So from equation 1 and 2, we'll get it PQ upon PR equals to QS upon SR. Therefore, this ratio is same. Then we can say that by converse of A.B.T, segment TS is an angle bisector of angle QPR. But suppose if you get the answer 8 upon 3, then is that this ratio is equal? No. Then we have to write it is not equal, and therefore this is not angle bisector. If you get the ratio different, then, but here we get the ratio equal, therefore this is angle bisector. Now we are going to see the sum which is related to the converse of BPT means basic proportionality theorem. Now see this. This is triangle ABC. This is segment DE. It is not given parallel. You have to prove that whether it is parallel or not. The values are given 3, 6, 5 and 10. Then again you have to find out the ratio. In triangle ABC, AD upon BD equals to 3 upon 6. 3 1 the 3 2 the. The ratio is 1 upon 2. For the second, you have to find out AE upon EC equals to 5 upon 10. 5 1 the 5 2 the. So what do you observe from these two? From 1 and 2, you will get AD upon BD equals to AE upon EC. It says that this ratio is equal. Therefore, we can say that by converse of BPT, segment DE is parallel to segment BC. These are the 5 sums which are related to basic proportionality theorem, angle bisector theorem, then intersection of 3 parallel lines, and converse of A.B.T and converse of B.P.T. So remember students, this you have to remember these 5 theorems. Thank you for today's lecture.